Larry Anglisano reporting at NBAA 2024 in Las Vegas. You know, the Pilatus PC-12 single-engine turboprop has got an earned reputation for being a pretty good all-around airplane, and the versatile PC-24 twin jet is not too far behind it. Let's learn more about this airplane with Pilatus' Andrew Westfall.
I'm here at NBAA in Las Vegas, and I'm standing in front of the Pilatus PC-24. We're happy to show this airplane to you, and I'm excited to show you some cool aspects of the airplane. So come with me, and we'll start a little tour. So we'll start at the nose here. This is the nose of the PC-24. In the radome up front, we have the Honeywell RDR 7000 weather radar. This gives us a good idea of what the weather is doing outside the airplane. It's a very capable radar, and allows the airplane to fly in not ideal conditions. Moving back from the nose of the airplane is the nose gear. As you know, the Pilatus PC-24 is certified to land on unpaved surfaces, including grass, gravel, snow, and this is the nose gear. It's quite beefy. It's quite a substantial nose gear, very strong. And on the back, you can see that there's a stone guard. This stone guard is to protect the fuselage from stones being shot up from the nose wheel on landing and takeoff on gravel. The nose guard is removable by hand. A technician is not required. There are two pins on the side. It's very easy to remove. It takes about a minute. And it protects the aircraft. So the PC-24 is a really sleek design. The skin of the aircraft is very clean. We don't have much sticking out from the skin aside from AOA probes, pitot probes, and an ice detection system. The windshield angle is very steep, so it's a really aerodynamic, slippery aircraft. The maximum cruise speed of the PC-24 is about 440 knots, and we can achieve that through a really clean design, as well as a very advanced wing design. So we're back on the wing of the PC-24. This is a clean sheet airplane. This is designed from the ground up. It is not the same size as the PC-12. It's actually quite a bit larger. It has a 501 cubic foot cabin and a clean sheet wing as well. There are actually over 50 different airfoils designed into this wing alone. You'll notice it's very clean. There are no stall fences, there are no vortice generators. It's a very clean wing, and it flies very clean as well. For demo purposes, we like to take the aircraft up to its service ceiling, which is 45,000 feet, and then we'll perform steep turns to the left and right, so 45-degree bank turns to the left and right, and a lot of aircraft like this in its class tend to vibrate and buffet, but due to this really well-designed airfoil, the airplane handles just as well at 45,000 feet as it does down at sea level. And that clean wing also allows the airplane to slow down to slow stall and approach speeds. The approach speed on this aircraft is actually about 91 knots, and that allows a greater margin for safety, as well as very short landing and takeoff distances. So double slotted Fowler flaps, 33 degrees double slotted Fowler flaps, you can slow the airplane down to about 90 knots for landing. So out here at the wingtip of the PC-24, you'll notice the larger aileron surfaces. This gives the airplane really good controllability at slow speeds, really good slow speed control. And you also notice it's a very clean wing. As I said before, there are no lift or drag devices on top of the wing. It's very clean. Moving inboard just a little bit on the wing, you can see these panels right here. So this is part of the spoiler system. These two panels can be used in the air as air brakes, as well as roll spoilers. If you engage the roll axis of the airplane more than a certain amount, these will come up and help the aircraft roll. And they're multifunction. They'll also deploy on landing. So these two panels will deploy, as well as the two main panels, and these function as the ground spoilers. And so that really helps us get the airplane on the ground, put weight on wheels, and dump the lift and stop quickly. New to this aircraft above serial number 501, these spoilers have been changed to carbon fiber, so they're much lighter. We're able to take about 160 pounds off the aircraft, and we're also able to certify the aircraft to a higher max takeoff weight, which is about 18,740 pounds. Moving a little bit inboard, right below the double slotted Fowler flaps, we'll see the main wheel here. Now, for an aircraft of this size, this is a really interesting wheel setup. It's a double main wheel, and by doing that, we're able to lower the tire pressure down to about 70 psi. Now, this gives us a lot of surface area for good braking action, as well as it absorbs some of the impact and possibly uneven ground from landing on unpaved surfaces. You'll also notice the main strut inside the landing gear. That's quite a well-built strut, and it allows for significant suspension travel to absorb some of the impact that may come from unpaved prepared field landings. Right next to the back of the wing on the left side of the aircraft, you'll notice the large cargo door. This cargo door is large enough to accommodate a standard size pallet with two 55-gallon oil drums on it, and you can drive a forklift up to the cargo door in the back to load cargo or other large bulky items with a forklift. As you can see inside the cargo area, it is a flat floor, and under the flat floor is a composite floorboard that's really strong, can handle high loads. Now, the seat tracks run the entire length of the airplane. There are 4 seat tracks, 2 on each side, and you can use the seat tracks to secure down cargo, baggage, or any other items that you may need to carry. So, stepping back from the cargo door, you'll see just behind the cargo door is the engine. This is the Williams FJ44-4A-QPM. I know that's a lot. We'll break it down a little bit. The FJ44 has been in use for a long time. These engines give about 3,400 pounds of thrust, 3,600 if required in an emergency, and they're full FADEC engines. And at cruise, you're going to burn about 900 pounds an hour. Something interesting about the Williams engine comes to the back, and this is the back of the nozzle. This is the exact nozzle, and this actually it doesn't just look good; it also provides functionality as well. So this nozzle uses something called the Coanda effect. The Coanda effect basically adds passive thrust vectoring. So at high power settings and low air speeds, the thrust, due to that extended lip on the top, due to that exact nozzle, the thrust is actually vectored up by about 3 degrees, and that's taking some of the weight off the nose wheel and helping the aircraft rotate a little bit earlier. And that helps us achieve such short runway distances. The PC-24 is able to take off on a 3,090-foot runway at sea level on an ISA day. So here we are at the back of the aircraft. As I mentioned before, the PC-24 has larger flight controls, and this gives us better controllability at low speeds. You'll notice here that the rudder of the PC-24 is quite large. Something interesting about this system is the yaw dam system that's coupled with the rudder. The yaw dam system can automatically sense a engine out scenario and apply the correct rudder trim to the active engine. And so the pilot, this is just one more system that is automated that decreases pilot workload and makes the aircraft a little bit safer to fly. The yaw dam system will automatically fix that in the case of unsymmetrical thrust. This is the 6-seat executive configuration. We have 6 executive seats in here. They're very comfortable. They are fully lie-flat seats. And they also have a footrest. So you have a full footrest and a full lie-flat seat. It's very comfortable for longer journeys. And it's just a comfortable seat in general. These seats are made in Broomfield, Colorado, by hand, where the Pilatus PC-24 is finished. This cabin is 501 cubic feet. Plenty of storage, with about 90 cubic feet of that is baggage storage in the back, which is accessible in flight, pressurized. It's inside the pressure vessel. The Pilatus PC-24 has 9 certified configurations. This is one of the most common configurations, which is the 6-seat. Another configuration we have is a 3-place divan. There's a side-facing divan located here in the left aft side of the cabin, and that gives you 3 positions. But this is the most common. The Pilatus PC-24 can hold 8 people and go 1,800 nautical miles. It can go about 2,000 nautical miles with 4 passengers and 2 pilots. The PC-24 is a single pilot certified aircraft. It's Part 23. So in the PC-24 cabin, we know that powering your electronics is a very important part. So we have a standard 115 volt plug down here, and you can power a laptop off of that. Wireless charging on top of the tray table cover is an option for this aircraft. And then we also have more power outlets inside the literature pocket. So we've got a 5 volt DC USB down there. And then in terms of storage, we have a tray table, a sidewall tray table, and sidewall tray table is covered in leather. It's a really nice surface to write on, very sturdy. There's not much give to it, and this is a fully flat surface all the way to the sidewall. So it's a good surface, and the tables actually swivel around a little bit. So by pulling up on this lever, I can push away from the sidewall, and I can actually move forward. And I can move forward, and I can get closer to the tray table, or I can move back away from the tray table. So welcome to the forward galley of the PC-24. In the forward galley, we have some crystal storage for basic drink glasses and drinks. There's a little toiletry storage area over here right next to the sink, so you can there's a bunch of storage up here right next to the sink. So this is a multi-use area. You have a little sink. New to the 500 series of the Pilatus PC-24 is a little bit of a smaller sink and a flat countertop, which gives you some more space to work. Down below we have some more crystal storage. This keeps it really nice and stable during flight, and also gives you, plenty of glasses, plenty of cups in flight. So down below that, this is the interesting part of the PC-24. This is actually where the lavatory is as well. As I said, it's multi-use. So to open the lav, we close that off to the cabin. Then all I do is just push that button, and this opens up the toilet from the sidewall. And you're actually closed off from the cabin by 2 hard surfaces. So you have 2 pocket doors on the back with full mirrors, as well as a hard door to close off the cockpit. And it's a pretty comfortable environment, and there's plenty of room and plenty of countertop space if it's needed. So this is the Honeywell ACE cockpit. This is the Honeywell Advanced Cockpit environment. Some nice large 12-inch MFDs and PFDs. Down here we have a touchscreen controller. So the entire avionics system is navigated and data entry is done through here through the touchscreen controller. Of course, we have our 2 throttle levers down here. They're full FADEC engines, so the start procedure is very straightforward. You flip the engine run switches to on, and you hit the starter button, and the FADEC computer takes care of the start process. Data entry is done through the touchscreen TSC touchscreen controller. However, in flight and sometimes in turbulent conditions, it's better to use the cursor control device. This is standard on most Pilatus products, including the PC-12 NGX, as well as this airplane, the PC-24. On the cursor control device, you have a selector switch over on the left side and a screen selector switch on the right side. So with my thumb, I can select, and with my pinky I can select which screen we're manipulating. On the forward of the cursor control device, there's a trackball, which allows me to move the cursor around on the MFD, PFD, or either MFD. One cool little aspect of this is when I hover the cursor over a data entry field. In this page, we're in the VREF field in the landing page. It will actually bring up a data entry point on the cursor control device. So if I hover this cursor over a data field, it'll bring up the data entry point on the touchscreen controller. That's just a little faster. It eliminates the pilot having to navigate more menus, so it's a little bit faster. It makes it a little bit easier for the pilot. And speaking of that, a lot of the systems on this aircraft are automated. All of the icing systems are automated. The environmental controls are automated. The pilot has really good access to the automated flight control system. Being a single pilot aircraft, a single pilot certified aircraft, there are a lot of automated systems, which makes it a lot safer to fly and takes away a lot of the pilot workload. The total cost of the PC-24 is about $13.5 million. If you'd like to learn more about the airplane, please visit our website at Pilatus Aircraft or contact your nearest sales dealer. I'd thank you, Larry, for giving us the opportunity to show this beautiful airplane to you.